Good day everyone, we are the Group 5. Now we will discuss about slider crank mechanism, single slider linkage, double slider linkage, and their inversion. The objectives of our reports are: first, learn about what a slider crank mechanism is, the different types, its working principles, and its real-world application. Second, identify the factors that contribute to the differences between single and double slider crank mechanism. Last, be familiarized with the inversions of single and double crank and double slider crank mechanism and their working principles. Slider crank mechanism. A slider crank mechanism is a type of mechanical system used to convert rotational motion into linear motion or vice versa. It is commonly found in engines, compressors, and other machinery, where rotary motion needs to be transformed into reciprocating motion or vice versa. So, yung slider crank mechanism is kino-convert niya yung pag-ikot into linear motion. So, mostly makikita natin to sa mga engines, compressors, and other machinery. Let's proceed to the parts of slider crank mechanism. The first one is crank, a rotating component that typically takes the form of a wheel or lever attached to a shaft. It provides the rotational motion that drives the system. Second one is the slider, a component that moves in a straight line. It is typically guided by a track or mechanism that ensure linear motion. Next one is connecting rod, a linkage that connects the crank to the slider. It transmits rotational motion of a crank into linear motion of the slider. Lastly is frame or housing. The structure that holds and support all the parts of the mechanism, ensuring that they are aligned and move as required. So, yung crank is siya yung bilog na nakalagay sa isang shaft na umikikot, then yung pag-ikot niya is nata-transfer sa connecting rod na yung connecting rod naman is siya yung dahilan para gumalaw yung slider ng linear motion. Then yung housing naman is sinusupport niya yung slider para para panatilihing aligned yung paggalaw niya.
Good day everyone, I am now going to tackle the two types of slider crank mechanism, which is the inline slider crank mechanism and the offset slider crank mechanism. Let's start with the inline slider crank mechanism. In inline slider crank mechanisms, the crankshaft and slider are aligned along the same plane, meaning the slider moves linearly along a path that is directly aligned with the crankshaft's rotational plane. As the crank rotates, it causes the connecting rod to push or pull on the slider, moving it back and forth in a straight line. It can be horizontally or vertically. This conversion from rotary to linear or linear motion to rotary motion depends on the mechanism's application. It is because same yung sa inline slider crank mechanisms, yung crank natin and the slider are on the same level. Straight line, same sila. Kaya, same din or consistent or uniform yung motion na nangyayari sa slider crank mechanism. And the other one is the offset slider crank mechanisms. In this design, the slider does not move directly in line with the crankshaft's axis. Instead, its path is offset to one side. This offset means that the connecting rod operates at an angle even when the crank is at a specific point in its rotation, rather than being aligned with the crank's axis katulad sa inline cycle na same level yung crank and the slider. In the offset slider crank mechanisms, yung slider natin, it can be sa taas, sa baba, or sa gitna ng ating crank. Shown sa ating example, nasa baba yung ating slider and then yung ating crank is umiikot siya. At a certain point, yung nagkakaroon siya ng angle with our connecting rod. This angle causes or affects the speed and force profile throughout the cycle. Nagkakaroon siya also ng non-symmetrical motion sa ating slider. Yung non-symmetrical motion na yun daw, sinasabi na when the slider moves towards the crank, mas mabilis siya. And then kapag naman papalayo na yung slider sa ating crank, slower siya compared dun sa papalapin na slider sa crank. It also has an impact on our force transmission. The offset can change the mechanical advantage, often resulting in a smoother force distribution or allowing greater force at a certain points of the cycle depending on the offset distance. Dahil nga dun sa greater force at a certain points, ginagamit yung ating offset slider crank mechanism sa mga internal combustion engines, pumps, compressors, presses, and punch machines na nag-i-improve sa performances or improve efficiency by optimizing combustion, timing, and force distribution or yung mga specific flow na kailangan for compressions, or particular parts of the cycle ng isang machine na nagagawa ng offset slider crank mechanism.
So, let's talk about the application of slider crank mechanism. So, the slider crank mechanism is a versatile mechanical system commonly used in various engineering applications. Its primary function is to convert rotary motion into a linear motion and vice versa. Here are some practical applications of the slider crank mechanism. So the first one is the internal combustion engines or the IC engines. Its application is to convert the linear motion of the piston into a rotational motion of the crankshaft. As fuel ignites, the piston moves up and down in the cylinder and the slider crank mechanism transmits this motion to rotate the crankshaft powering the vehicle. So the second one is the reciprocating pumps. Its application is to convert rotary motion into linear motion to operate pump piston. So the crankshaft drives a piston which moves back and forth, forcing liquid or gas through the pump. So the next one is the compressors. Its application is used in reciprocating compressors to convert rotary motion into linear motion, enabling gas compression. So the mechanism drives the piston in a cylinder, compressing gases which are used in cooling systems or industrial processes. So the next one is steam engines. Its application is historically used to convert the piston linear motion into rotary motion to drive a wheel or mechanical load. Steam pressure drives the piston which moves back and forth, and this motion is transferred to the crankshaft to power machinery or transformation. So the next one is the bicycle pedals. Its application is a simplified form of slider crank mechanism that converts the rotational motion of the pedals into linear motion to drive the wheels. So pedaling moves the crank which turns the wheel to the chain mechanism. So the next one is machine tools or shapers and slatters. Its application is to convert rotary motion to linear motion in machine tools for cutting and shaping materials. So the slider crank mechanism moves the cutting tool back and forth to shape or cut metal parts with precision. Then the next one is robotics or linear actuators. Its application is used in robotic arms and actuators to generate controlled linear motion. Rotary motion from an electric motor is converted into linear motion for precise movement or robotic arms or tools. So the next one is aircraft engine mechanism. Its application is to convert the linear motion of pistons into rotational motion to drive a propeller. So the piston moves up and down in response to fuel combustion. This motion is transmitted to rotate the propeller, generating thrust. So the next one is hydraulic presses. Its application is used to convert rotary motion into linear motion to drive a ram or press. The mechanism drives the press or rams to apply force for shaping or molding materials. So the last one is clock and watches. Its application is used in mechanical clocks to move the hands by converting rotary motion into a linear motion. So the mechanism ensures the hands of the clock move smoothly and at the correct speed by converting the rotational movement from the gears. That's all. Thank you.
Good day everyone, my name is Aaron James V. Pincaro, and today I will be talking about the single slider crank chain or the single slider crank mechanism. So let us first define what it means. So it is said here that it is a modification of the basic 4-bar chain. So what does that mean? The basic 4-bar chain is a kinematic chain that contains 4 turning pairs, and when we switch one of those pairs into a sliding pair, it becomes a single slider crank mechanism. But when we switch 2 of those pairs into a sliding pair, it becomes a double slider crank mechanism, which will be discussed later on by my fellow reporters. But for now, we will be focusing on the single slider crank mechanism. So, as I've said, it consists of 1 sliding pair and 3 turning pairs. So, it is a kinematic chain that converts rotary motion into a reciprocating or a back and forth repetitive linear motion and vice versa. So, we may ask here that how does it differ from a slider crank mechanism? So, the short answer is it does not, because most slider crank mechanism uses single sliders. That's why they're basically the same, but in here we will discuss it in a much deeper way and describe and look at the figure to better understand how it works. So for the next slide, we can see the figure. So we will discuss how does it work. So how does it work? So when the crank rotates, the slider moves along a straight line and vice versa. And why is that? They move relatively constrained to one another due to the connecting rod that links the crank and the slider. So they act as if a driver and a follower. So let's say that the crank is our driver in this case. So when the crank rotates, the slider will move relative to the motion of the crank as it becomes the follower. So the good thing about this single slider crank mechanism is that the power can be reversed, wherein the slider can become the input power or the driver, and the crank can become the output power or the follower. So this is what basically happens in internal combustion engines, wherein the tiny explosion drives the slider into an up and down motion, which then drives the crank into a rotary motion. So the connecting rod that drives the wheel around for the first 180 degrees of the wheel's rotation while the slider travels outside of the guides. So the connecting rod pushes the wheel back around to complete the rotation when the slider begins to move back into its original position, causing the crank to have one full revolution. So we can also see in the figure that link 1 corresponds to the frame, which is the fixed point or the stationary part of the engine, and link 2 is the crank, link 3 is the connecting rod that connects the crank and the crosshead or the slider, and link 4 is the crosshead or the slider. So as I've said before, that a single slider crank mechanism consists of 1 sliding pair and 3 turning pairs. So here, the single sliding pair is the pair of links 1 and 4, which is the frame and the slider. And the 3 turning pairs are the pairs of link 1 and 2, link 2 and 3, and link 3 and 4. So that's how the basic principle of the single slider crank mechanism work. So the advantages of this kind of mechanism is that it has low cost, a reduced weight, and less wear and clearance due to the reduced number of parts using only a single slider. So these are mostly used in These single slider crank mechanism are mostly used in reciprocating combustion engines or reciprocating pumps. So that's all there is to it for the single slider crank mechanism. Now let's move on to the inversions of the single slider crank mechanism and its principles.
Hello everyone, let us now talk about the inversion of single slider crank mechanism. In the inversion of single crank mechanism, different types of motion can be achieved by fixing different links, resulting in 4 possible inversion. Let us now talk about the different types of inversion so that we can understand. First inversion, the crank is fixed, which is the link 1. The first inversion occurs when the crank is fixed in place. In this configuration, the connecting rod, which is the link 2, rotates around the fixed crank, causing the frame or the link 3 to oscillate and the slider or the link 4 to move in reciprocating manner. In this, the fixed crank acts as the central pivot point around which the connecting rods moves. These movements result in the back and forth linear motion of the slider, creating an effective conversion of rotational motion to linear motion. These conversions are usually used in internal combustion engines, steam engines, reciprocating compressors, and pumps. And now, let us talk about the second inversion, where the connecting rod is fixed. The second inversion involves fixing the connecting rod. In this configuration, the crank rotates around its pivot connected to link 2, driving the coupler to move. This motion in turn causes the slider to reciprocate and the frame remains as stationary as the base. In this, when the crank rotates, it transmits motion to the coupler, which guides the reciprocating movement of the slider. This setup converts rotational motion into oscillatory or linear output. These inversions are commonly found in Whitworth quick return mechanism and some rotary engines like Gnome engines. And now, let us talk about the third inversion, where the coupler is fixed or the link 3. The third inversion occurs when the coupler, the link 3, is fixed in place. In this configuration, the crank or the link 1 rotates and drives the connecting rod or the link 2, which in turn causes the slider or the link 4 to oscillate back and forth. With the coupler fixed, it acts as the stationary frame of the mechanism. The crank rotates about its pivot point, transferring motion through the connecting rod. This results in the slider pivoting around its joint with the link 3, creating a oscillatory motion. The fixed coupler serves as a support structure, allowing the remaining links to move relative to it and generate complex and to control the motion. The third inversion of a 4-bar linkage is used in mechanism, where the coupler must remain stationary while enabling the other parts to move, such as specific types of levers, mechanical presses, or guiding systems in machinery that requires constrained oscillatory or rotary motion. And lastly, the fourth inversion, where the slider is fixed or the link 4. The fourth inversion occurs when the slider or the link 4 is fixed in place. In this inversion, the crank or the link 1 rotates and drives the connecting rod, which is the link 2, which in turn causes the frame or the link 3 to oscillate around its pivot point. With the slider fixed, it acts as the stationary frame for the system. The crank rotates around its joint, transmitting motion through the connecting rod. This movement results in frame moving in a oscillatory manner around the fixed pivot point on the slider. The oscillation of frame occurs as the crank continues to rotate, pushing and pulling the connecting rod back and forth. This inversion utilized in pendulum pumps, bull engines, and hand pumps. And that's all for the inversion crank mechanism. Thanks for listening.
Good morning, everyone. I will be discussing double slider linkage. So, unang-una sa lahat, define muna natin ang slider linkage. Ano ba ang ginagawa ng double slider linkage? Una-una, kino-convert niya ang circular motion into a fixed sinusoidal wave. However, kailangan ba na may pattern yung wave? Yes, of course. And it also needs a 4 interconnected links. Ang 4 links na yan ay dalawang revolution joints na kailangan para i-create yung circular motion at dalawang sliding joints, which is to create and translate it into a sliding sinusoidal motion. So let's pakita muna natin sa GIF kung paano siya gumagalaw. So ganyan siya gumagalaw, and nakikita nyo naman na exact yung sizes ng sliders sa isa't isa. So perfectly na in sync or in same size yung sliders. Anong mangyari nun sa sinusoidal wave natin? So ang magiging wave natin nun, yung paakyat at yung pababa, yung wavelength rin niya equal sa isa't isa. So ang crest pati ang toro, equal niyan sila sa isa't isa pagka equal ang sliding joints. However, paano kung hindi siya equal? Masasabi mo ba? So ganito niyan. Ang mangyayari nun sa wave natin, mag-iiba yung height pati yung wavelength. It depends. So kuwari, ang slider natin ay unequal siya. So parang liliit ang wave natin sa yung wave natin or yung crest natin pagka nag-iba yung isang part ng linkage. So yung slider, what if unequal siya nga? Yun nga, yung dahil mas mabilis na magstay sa crest or sa toro yung isang slider dahil mas maikli yung time na nandun siya dahil mas maikli yung slider. Para naman kung bent yung slider natin. So mag-iiba rin yung shape ng sinusoidal wave natin. At mag-iiba siya na pwedeng ganyan. Yung malaki yung crest, maliit yung toro. Kasi mas ang time it takes na mag-exist siya sa x-axis or sa x-axis ay iba kumpara dahil sa pagka-bend ng slider natin. So ganun yun. Pero ang mangyari naman, may pattern siya. May pattern yung mismong wave na nangyari. However, hindi naman exact na yung first wave na nangyari, yung half wave na yun, eh equal siya sa pangalawa na susunod na yung wave. Yung crest, kumbaga, yung crest at yung toro ay hindi hindi siya nagiging equal. However, may pattern siya. So, umuulit lang yung waves na nabubuo sa isang slider. So, next naman, ito yung brief history ng double slider linkage. So, ginawa siya ni Franz Rehluix. At ngayon, so far, yung Cornell University may 220 na model siya. Hindi necessarily mga double slider linkage ang mga models na to. Pero one of it is double slider linkage. Na yun, ginawa siya sa 1882. So, remember nyo na lang yung mga bagay na yan. Baka kasi magpakita sa quiz. Okay? So, sunod naman tayo. So, ano yung mga parts? Yan nga, yung frame na nag-provide ng structure niya, yung first slider at yung second slider, which is yung horizontally, vertically, at kailangan na kasamang conjunction or sabay silang gumagalaw sa isa't isa, ang first at slider. Ngayon, ang connecting bar. So, ano yung connecting bar? Nag-connect siya sa two sliders nga para mas restrict yung motion nila. At ang crank naman na nagsusupply ng power, or kung yung circular rotation niya, yun nga, ang siya yung nagpo-provide ng circular rotation. So, ang connecting rod naman, linkage to the crank and slider, which is, yun nga, yung itong mga part na to. Ayan, yung gumagalaw na stick. So, yun yung nagsisilbing connecting rod. Tapos ang connecting bar, itong butas na makikita nyo. So, sa next slide, makikita nyo naman. I-explain ko naman. So, yan ang primitive na stripped down na version ng double sliding linkage. So, ito nga. Yan, sa taas. So, ito ang connecting rod. At connecting bar naman to. Yung frames, sabihin na-strip down na kasi yung frame, pero ito na, masasabi na yan yung mga frame para mag-restrict ng tawag dito ng motion at ma-provide ma-provide yung structure niya, kumbaga. Ayun. Tapos yung crank, wala dito yung crank, pero nagsusupply siya ng motion. So ito lang yung connecting rod at ang crank nasa loob nito na nagsusupply ng, wala siyang crank, pero yung supply na circular power ay nandito sa part na to. Ayan, pagka pinlay ko, medyo mabagal lang siya. Ayan. So ayan, makikita nyo naman na nare-restrict yung motion at kailangan sabay yung connecting bar, sabay sila. So, ayun na ang double sliding mechanism. So, ano ba ang uses ng double sliding mechanism? So, ito nga, madalas na ginagamit sa shaping machines, engines rin, which is diesel and gasoline engines. Paminsan, mas halata sa single crank mechanism yung mga engine. Kasi, yun nga, yung mga piston, single cranks nila. Pero ginagamitan rin ng single slider. Ang ginagamitan naman ng double slider rin naman yung mga engines, pati yung shaping machines. Mas pronounced siya sa shaping machines kasi kailangan ng sinusoidal waves. Paminsan, ang mga precise na sinusoidal waves, yung mga shapes na kailangan gawin ng shaping machine. So, ito, yung scanning acoustic microscopy, ay recent lang yan. So, tinatry nilang gamitin to sa experimental na microscopy system. So, ayun nga yung mga uses niya. So, sa advantages naman natin, so, yun nga, yung high mechanical advantage dahil sa dalawang slider and kailangan mo ng substantial force na i-provide yon. Ngayon, ang double slider linkage nakapag-use ng X and Y axis na forces para ma-provide yung more force na sa system. Kasi yung forces na nagagamit ay dalawa. So, compact design nga. Compact siya dahil napagsama na natin yung X and Y axis sa pagbuo ng motion ng sinusoidal wave. Smooth motion naman para sa sinusoidal wave at ideal nga to sa mga shaping machines na kailangan precise yung mga devices na gagamitin or yung motion na bubuin natin. So, susunod naman, versatility and low cost. So, versatile nga siya dahil compact nga siya, mas marami yung choices na pwede mo ilagay dahil sa marami siyang forces na nako-cover nga sa sinusoidal wave. And low cost siya dahil compact and na gagamit siya in wide variety of uses. And yun na po ang part ko. And yung inversion of double slider linkage gaya nga nung sa first part ko, hindi ko na din-discuss muna yung Scotch yoke kasi di-discuss rin sa next reporter, which is yung inversion of double slider crank linkage na i-perform naman ni JL. So, yun po, and thank you.
Now let's proceed to the inversion of double slider linkage. First, let's define the inversion of double slider linkage. The inversion of a double slider linkage involves fixing a different link in the mechanism, which changes its motion characteristics. A double slider linkage is a 4-bar mechanism with 2 sliding joints and 2 rotating joints, where the sliders move in straight lines. We have 3 major inversions of double slider linkage, namely elliptical trammel, Scotch yoke mechanism, and Oldham's coupling. First, let's have the elliptical trammel. The elliptical trammel, also known as the trammel of Archimedes, is a mechanical device used to draw an exact ellipse. The device consists of 2 sliding arms and a crosspiece attached to a central shaft where the ends of the arms slide in slots or grooves, perpendicular to each other. Dito sa elliptical trammel, we have 4 links. First link being the frame, which is yung fixed link natin dito. And yung second link is yung rod, PB. A third link is yung first slider, and ang fourth link ay yung second slider. As you can see dito sa illustration, one end ng rod is connected sa second slider, while yung center naman ng rod is connected sa first slider. Habang gumagalaw horizontally at vertically yung dalawang sliders na yon, yung free moving na end ng rod, which is yung point P, ay nagte-trace or nagke-create ng ellipse. Here is a clip for you to better understand. For the second inversion, we have the Scotch yoke mechanism. The Scotch yoke mechanism is used to convert rotary motion to linear motion or vice versa. This mechanism is simple but effective and is often found in machines where smooth linear motion is required. Dito sa Scotch yoke mechanism, we have 4 links din. Yung first link is yung frame, second link is yung crank, third link is yung slider, and yung fourth link naman is yung yoke. As you can see sa illustration, yung one end ng crank is connected sa fixed central frame, and yung one end naman is connected siya sa slider. Yung pag-ikot ng crank na yon is nagkakos for the slider to slide inside the yoke. Thus, the rotary motion ng crank ay nako-convert into reciprocating motion inside the yoke. Here is a clip ulit for you to better understand how Scotch yoke mechanism works. For the third and last inversion, we have the Oldham's coupling. The Oldham's coupling is a type of flexible coupling used to connect 2 shafts that are slightly misaligned, typically parallel but offset. It allows for flexibility and alignment, making it suitable for power transmission where precision alignment is difficult to maintain. Dito sa inversion na to, ang first link natin is yung frame, yung second link natin is yung shaft and flange na nasa left hand side, third link natin is yung intermediate piece, which is yung piece na nasa gitna ng dalawang flange,
And yung fourth link natin is yung shaft and flange na nasa right hand side. Once na umikot yung isang shaft, yung rotor motion na yun is matatransmit sa kabilang shaft using the intermediate piece. Habang umiikot yon, yung intermediate piece ay nag-slide sa grooves. Here is the clip ulit para mas maintindihan nyo. That concludes our report. Thank you for listening.